Oh, thank you. Hi, Emily. Hi, Emily. Can you hear us?
Yep. Hi.
How are you today?
I'm doing good. How are you?
Really good, thanks. So what brought you to our booth?
Well, a few days ago, I was in a Zoom meeting with Danielle, and I just thought it would be cool to hear more about what she does.
Awesome. Cool. Welcome back. Well, you've met Danielle. I'm Rachel. I'm the COO.
And we really have no idea what we're supposed to do. Yeah, go ahead.
This is like a booth we would have at a trade show, except it's virtual. So we can just discuss, we can answer any questions you have. We put kind of a video on our page there. I don't know if you had a chance to watch that, but we kind of go through our pitch deck. Our website link is there, but it's not up and running just yet. It will be very soon.
And we were kind of thinking maybe we would just we have a more updated pitch deck that we could totally go through. We could pull up and share our screen. You can ask any questions, or we could just go through it if you want.
You have our undivided attention. Whatever you would like to know.
You're muted. I don't know if you know that.
Well, I don't exactly have any specific questions right now, but I would love to hear just like more of how that hydrogen project is going.
Cool.
Here, I'll go ahead and do a screen share, Emily, and we'll kind of give you a broad overview, and then if you have any questions, we can certainly talk about that after. Oh, excuse me.
And feel free to jump in anytime.
All right, so Danielle.
Yeah, so we're Happy Takeoff. I'm the founder, Rachel's the co-founder, and together we are Happy Takeoff. And yes.
There we go. Okay.
So there's our team. Dominic wanted to be here. She is supposed to be joining us later today, but she's busy keeping things running, keeping the world running. She's in Kansas City. We are in Wichita. And so our core values, we totally believe that the planet is number one, and everything that we do, we want the planet to be first. And so that includes working together, business partners. We don't really want to get into partnerships with people that are, still contributing to greenhouse gas emissions. And we certainly believe nature is a very big part of that. We don't want to destroy nature. And we also want to foster innovation. And all of that kind of circles around the planet. As I said, we think that is the most important thing. And so if you've been following all week, you probably saw in the poll, this was from, was it Wednesday? Yeah, Wednesday's poll, that they asked what the biggest challenge was for the widespread use of orbs. And I'm not really sure why we're calling them orbs now. We've been calling them eVTOLs for years, and now all of a sudden we're calling them orbs, but we're just kind of going with it. So as you see, the biggest challenge people thought was infrastructure, and we 100% agree with that. When we got into this, we were kind of looking at all of the use cases for flying taxis, drones, and all of the things that they could really improve the world on. Number one, if they were electric, they could reduce emissions if we were using them to travel. They could, give rural communities access to better healthcare. You could use a drone to deliver an organ, all types of things. And the thing that was missing throughout every use case was infrastructure. Where are they going to take off and land from? How are they going to recharge or refuel? And that just doesn't exist yet. And so that's what we decided to really focus on for our business. And the biggest challenge to infrastructure is power, 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 power. Where is that power going to come from? If you're wanting to charge, you know, some of these flying taxis that we've been seeing, or orb, or whatever you want to call it, a lot of times they're going to use like 1 to 3 megawatts of power, and you can't just pull 1 to 3 megawatts from the grid at any given time. That's going to put a really big burden on the grid. And so, you know, we wanted to look at ways that we could provide that type of power without hurting the grid. Especially if you're in like a rural area, you're probably not going to have access to 1 to 3 megawatts.
And not to mention fossil fuels and emissions that are involved in recharging and producing and recycling lithium ion technologies.
Exactly. And so for the current air taxi requirements, or orb, or whatever you want to call it, eVTOL, all of it's kind of the same thing. The requirements are the energy density is 500 watt hours per kilogram, specific energy 1500 watts per kilogram, and then the charge time really needs to be about 10 minutes to get, so you have a lot of them going to and from your locations. And with lithium ion technology, your sorry, Mike, Rachel is doing something on the computer and it's distracting me. Just give me 1 second. All right, we good. All right, so with your current lithium ion technology, your energy density just isn't there. It's only about 180 watt hours per kilogram. And your specific power looks good, but the charge time is really long. And even if, like I said on the previous slide, even if you can get that charge time to where it needs to be, you're going to be pulling a lot of power probably from the grid. And so we just don't think that lithium ion batteries are the way to go. Another thing to consider is, I think we talk about it on the next slide. Well, I'll just go ahead and talk to it. I can't remember if we have a slide in here about this or not, but actually it's later. So yeah, we'll go to the next one.
Yeah, so this slide kind of represents, if you can see behind us, our dry erase board. We're looking at the different sources of renewable clean energies and doing some calculations and finding out which one we could use to produce the highest amount of hydrogen fuel. And our goal is to utilize 1 acre of land only. And so we want to be very dense in production. As technology currently stands, the high efficiency photovoltaic solar cells are the best option, with those who can make 142 kilograms of hydrogen per day, running that electricity through an electrolyzer and producing the hydrogen on site. Something else that is really interesting to us is you can see here it says solar parabolic. And as the current technology stands, we could make 99 kilograms per day. But what makes us interested in this technology is under power generated, you'll notice this as NA. That's because it doesn't use electricity as an intermediary, so it doesn't have to use an electrolyzer to create hydrogen fuel. And so we're investigating different ways that we can kind of condense this technology into a smaller space, and we're trying to make that as efficient as the high efficiency photovoltaic cells currently are. We also saw that wind and water wouldn't really be viable options for us. So really we're looking at solar at this time. We've also researched geothermal power, but we're thinking that for our application and our small footprint, that solar is probably going to be the best bang for the buck. We're also working with NREL, the National Renewable Energy Labs. So we're sorry, I get antsy.
No, you're good. And then go ahead before you jump to the next slide.
I was just going to say, we're working with them to kind of research and develop this technology as well.
Yeah, and if you look at the far right column, the reason why we're looking at a kilogram is we're looking at basically like a 4,000 pound eVTOL or orb, and a kilogram is what it would take to fuel that up to power 4,000 pound aircraft. And that also, and the reason why we really like hydrogen is that gives you this really nice range of like 200 to 300 miles, where with lithium ion, you're probably not going to see that type of range, maybe ever. There's a lot of debate on it. But even if battery technology if it keeps advancing exponentially like we've been seeing, even if it does do that, you have the recyclability, the overhaul of the batteries, which is not a renewable process at all. And so it could get really messy. We could get ourselves into the same type of situation that we've gotten with fossil fuels if we have this widespread use of ginormous lithium ion battery packs. So we just really think that hydrogen is the way to go. You get the range you're looking for. So you can go from LA to San Francisco, Wichita to Kansas City, something that Rachel and I are interested in, living here in Wichita. And so anyway, so that's why we picked that kilogram per day. And eventually we would want to scale that up. So as Rachel said, we're looking at an acre. We're just looking at making a kilogram per day. That's to start, but we would want to scale that way up. And that's going to require us getting very creative with how we capture that sunlight. And so that's why
100 kilograms a day.
Oh, sorry. Yeah, exactly. 100 kilograms a day. So we would want to scale that up. So our target is to start with a kilogram per day off of 100% renewable sources, and then scale up to where we're getting to 100 kilograms a day, which is going to take some creative methods. And then this is kind of what we were just saying. You can do this one if you want.
Yeah, I mean, this is just kind of a graphical representation of what we were just talking about. So the renewable energy sources, you know, we've looked into all of these. We've also looked at geothermal. Maybe we should add that in there too. The way we see this, and you know, this is subject to further research, of course, but we see this, we see us as collecting this power into an arbitrage battery unit. And we intend to connect that to the grid, and the grid would be, we would be able to use that in emergencies if we needed it in a pinch. But as you can see by the arrow, we're putting way more energy into the grid. And you know, we hope to kind of lessen the carbon footprint by doing so. And of course, this represents if we utilize technology that uses electricity as an intermediary. So it wouldn't look like this if it was a parabolic system. But if we're using electricity, then we're going to store that electricity in a 1 to 3 megawatt battery storage device, and then use that electricity to power an on-site hydrogen production facility, most likely an electrolyzer. That's the most efficient at this time. On average, the current electrolyzer technology produces 1 kilogram of hydrogen per every 39 kilowatt hours of electricity. And that was one of the conversion factors we used in our math there. So we see this as all taking place right on site. So you don't have the constraints of transporting hydrogen fuels. It's going to be created there and put right into the storage tank, and then available for aircraft that would land on our landing pad. They'd be able to refuel probably less than 10 minutes and be on their way.
And this could be viable for a hydrogen powered aircraft or a fuel cell. So it doesn't just have to be a hydrogen fuel cell. And then kind of to just add to what Rachel said, the transportation. So the reason in that block where you see the on-site H2 production, the reason that's probably the biggest sort of our secret sauce in our vision is that the biggest constraint with hydrogen is the production and then the transportation of it. It's expensive to produce, and then transporting it is so inefficient because it is not dense at all. And so if you're going to use a big truck to transport a bunch of hydrogen, you usually end up spending more in the gas that you would use to transport it than the hydrogen would even be worth. So it kind of just like ends up canceling out the efficiency of hydrogen by transporting it. So the real beauty and the real advantage lies in if you can make that hydrogen where you're going to use it. And so that's really what we're focused on.
Emily, do you have any questions so far? Well, just let us know if you do. We'll show you this short video. This is that parabolic technology we were referencing earlier. So in this example, it looks like a satellite dish, and all the mirrors kind of focus the sunlight onto one spot. And it uses the heat generated by that device to drive the process of hydrogen production. So it takes a water molecule and splits it into hydrogen and oxygen. that's the technology as it stands today. We're investigating other ways to make this more efficient. So that's kind of what that looks like. This is, well, I'll let you talk on this.
Yeah, so this is us just testing out different materials. So on the left, you see we're kind of getting some bubbles. So that was exciting. That's just using total sunlight. The middle picture is 3 different materials. One of them is aluminum. I can't remember what the one in the middle is aluminum. Those are 2 different types of aluminum. I think the one on the far right in the parabola, like the furthest in the back, that one is like a clad aluminum. And we were just sort of testing out. And then in the middle there is like a black body radiation pipe. And so we were just heating up the water in that pipe and measuring which one of those. And obviously you can kind of see the furthest one away is the most reflective. And then, and now we've since learned that mirrors would be the best way to do this. They're very hard to put in a parabolic shape, but that's something that we want to look into more and just kind of focus that energy into that center pipe using heat. And so that one would bypass electricity completely. And then on the right, we were looking at the dishes, kind of like you saw in the video. And we're just basically, we made this is from one of those solar blankets from Walmart. They're like $2, and we kind of just wrapped it around a hula hoop and pumped it with air and then put some epoxy on it. And the idea of this, and yeah, we could have used other things for a parabolic dish, but we wanted to make it for as cheap as possible so that anybody could really make this, and it didn't require a bunch of expensive materials to sort of collect this energy from the sun. And so that's just us proving out that these technologies work, and then obviously we want to scale up and do it on a bigger scale.
So yeah, the one on the right, the dish, that's kind of like the one that we saw in the video.
Mm-hmm.
And then the one in the middle, that's what's called a parabolic trough. And we think that if we were to develop it as a parabolic trough, then we may be able to generate more hydrogen per acre. So that's one of the things we'll be investigating with NRail.
And this just kind of goes over the operating costs. Some people say that, you know, lithium-ion batteries are cheaper to operate, but if you look at the overall cost of the lifetime of the vehicle, it's actually a lot cheaper to use hydrogen. And I won't go too deep into this slide. We can talk about this offline if you're interested, but we looked at basically San Francisco to LA or LA to San Francisco with an electric aircraft, and looked at 10 flights per day because that's sort of something that they're doing. And we compared lithium ion with a hydrogen vehicle. And if you did 10 flights per day over the course of a year, you stand to save about $675,000 a year just by using hydrogen. This kind of goes back into what I was talking about earlier. We should probably move this slide actually to that other one. But when I was saying that the charge time for batteries, it takes so long. And so to really make a business case for lithium ion batteries, you kind of need 2 of them charging while 1 of them is in the air. And that means that you're going to need 3 times the fleet as you would if you were using, and we're calling it a FC VTOL, basically a fuel cell eVTOL. We just kind of threw that acronym but together. I guess it would be a FC orb now after this week. But anyway, you're going to need 1/3 of the fleet if you use hydrogen fuel cells. And so that comes to, if you're looking at 10,000 aircraft in your fleet at a 4,000 pound aircraft, and then $50 per pound. And I want to stress $50 per pound is very optimistic. Composite aircrafts are not that cheap to make right now, but if we could reach that price point, so your savings could be even better if that was more expensive. But we're just going to say $50 per pound right now, just for simplicity. You would save about $1.3 billion over just from your fleet production costs by using hydrogen over battery.
Yeah, and this is assuming that the vehicles are recharging as opposed to using like a battery swap technology. Even if you use battery swap technology, lithium ion as it is today, of all the different companies we've looked at, it seems like they're getting about a 60-minute flight range, and they're able to cover about 1 mile a minute. So 60 minutes and 60 miles is kind of the range that they're looking at. By comparison, we're looking at some hydrogen fuel cell companies who are utilizing this hydrogen technology. They're getting between 2 and 300 using hydrogen technology before they'll have to land. So, even if you land and swap your battery and you're flying again, you're still constrained by your flight range. So, kind of a use case that shows this example. In this case, we kind of took that San Francisco to Los Angeles trip that we mentioned before, because it's such a congested route, and there are so many people that use this route. So we see this as being a huge potential market for this tech. On the left, like I said, flight range is about 60 miles. So with that limited flight range, you would require 8 charging stations to be able to cover that distance, and you'd have to land at each one and either recharge or swap batteries. And we estimate that installing the infrastructure for lithium-ion batteries, it's probably going to be around $2 million per station. So your total investment there is going to be $16 million to get that infrastructure running for that trip. By comparison, on the right side, we show that same trip utilizing the hydrogen fuel cell technology. And we're kind of partnering with another company investigating this, and they're claiming their flight range is 300 miles currently. So we used 250 to be conservative. That same trip with a 250-mile flight range only requires 3 stations as opposed to 8. And they're still developing their tech. So once they're able to cover more flight range, then it should only take 2 stations. But that's not really our tech. We're kind of waiting for them on that one, but that's our goal, like 1 station at each side. So if you need 3 stations, it's going to cost a little more per station. Our goal is 3.5 million per station. You'd have a total savings of 5.5 million just to get that infrastructure up and going.
With current technology.
With current tech, yes. And so here's another example. In this case, we used a hypothetical company on the East Coast. This company has 7 locations that are listed kind of on the right side there. So same principles as the last slide, except they're covering a much larger area and connecting more locations. So with lithium-ion tech, they would need 29 stations by our math to cover the entire distance and connect all of their locations. Whereas with hydrogen fuel cells, they would only need to install 1 at each of their locations, and then there would be 2 spots where they would need to add an extra one, so 9 stations total. So in this scenario, that company would save $26.5 million in implementing ground infrastructure. And so this is kind of the vision that we have. So we want to kind of spend the rest of this year, we want to do market research. We're looking into the renewable energy technologies, and we're finding out which one is going to be most viable and where we can kind of innovate those technologies to be more efficient per square foot. We're also developing a customer base. We're in talks with several companies right now who are using hydrogen fuel cell technology. We've identified that this is a huge need. And nobody is approaching the problem of creating this fuel using 100% clean energy. So we're planning on spending the rest of the year doing that type of research. By the first quarter of 2021, we want to be developing our prototype and testing. And we'll be working with, like we said earlier, with NREL, and we have another firm that's going to assist with the testing part. And it's going to be kind of more of a co-op effort. Because it's a big undertaking, but we anticipate that to take about a year. So by Q1 2022, we want to kind of finalize, and we're going to prepare for manufacturing. We're going to get our supply chain in order. We're going to get our factories in order, and then by the third quarter of 2022, we want to be producing our technology. And this time frame is very intentionally, it's very intentional that it ends at the first quarter of 2023, because experts project that 2023 is going to be the year of electric aviation, when those vehicles are going to start going into production, and they're going to need ground infrastructure support to run their vehicles. So we want to be positioned in 2023 where we are fully prepared to provide that needed infrastructure tech. So that's our presentation, Emily. Thank you so much for listening.
Yeah, thank you.
So I had a few questions, but you immediately answered those after I thought of them. But I was wondering, how did you like get into this? How did you, what was your initial interest in using hydrogen?
Sure. So it started when I was in college in aerospace engineering, and we were tasked with designing an aircraft. They didn't tell us what it had to look like. They just kind of gave us the mission, like what it needed to be able to do. And one of the things that was a really tight requirement was the range and the flight time. And it had to be electric. So that was really the only requirement. They gave us this range, they gave us this flight time, and they said it had to be electric. Oh, and they also gave us the payload, and the payload was 1,000. And it's very, very similar to the requirements that Uber came out with for the, I don't know if you've read the white paper, or it's not on the white paper, it's on the Uber urban air mobility requirements. So anyway, I think it's 1,000-pound payload. The range is like 60 miles. Our range was about 200 miles. And I don't remember what our flight time was, but it was long. And so we spent months researching batteries. So we had come up with this really cool aircraft design, but we kept struggling with the batteries because the batteries kept getting bigger, which kept making the aircraft get heavier, which kept making our wingspan get bigger. And then it was like getting to this point where we were going to have like this 300-foot wingspan to support, to give us enough lift that we were needing from these massive batteries. And so we just kept researching, and then we stumbled upon hydrogen, and we looked at the Phantom Eye and got some ideas from that. And we were like, oh, wow, you can get a lot of range with hydrogen. And so we decided that hydrogen was the way to go. And so that was several years ago, but I've always kind of had in the back of my mind, like I knew what those limitations were for hydrogen. And then it's interesting because then when Rachel joined Happy Takeoff, we were just looking at lithium ion infrastructure, but over the time we've still been like watching what these other companies have been doing with hydrogen, and like, man, it'd be cool if we could do something to support them with hydrogen. And then
yeah, absolutely. And so yeah, we've been very interested in the infrastructure and landing pads for quite some time. We were just trying to find our niche, or we were trying to find a hole that needed to be filled within the industry. And then we joined a conference on hydrogen fuel cells, and that's what kind of got us in that direction. We didn't really see, using lithium tech, that there was really a place that we wanted to go with that. But once we kind of started looking into hydrogen, we noticed that there's a huge opportunity there, and there's as far as we know, there are no other companies that are working on developing this type of technology that'll be 100% clean energy production of that fuel.
For aviation.
For aviation.
Yeah, they're doing it with trucks. And so if you look at like heavy duty trucks in Europe, and then you can look in California, there are some locations that are doing this. And really the key is making that hydrogen on site. And then also, to further answer your question, Emily, we're like on our core values, like that is so important to us. We really are passionate about the planet and global warming and emissions, and as engineers, and actually Rachel's technically a medical doctor, but I feel like she's naturally an engineer. She learns really quickly, and she's super smart, genius. That's why I snatched her up.
Bioengineer.
Yeah. And so we're just super passionate about emissions, and we both agree that we don't really think batteries are really good for short term. They're really good it's a good alternative to fossil fuels right now, but in the long term, we just don't see batteries being the answer because one, lithium, that is not a very renewable process. Mining that lithium, it is a limited resource and it's not very abundant in the United States. So there could be trade issues. There could be all kinds of problems with mining lithium. And then recycling the batteries. What are we going to do with all of these batteries? You know, we use lithium ion regularly right now in our phones and all these other, you know, devices. But if you'd have looked at, you know, how many cars, like it hasn't really been an issue yet because there's not that many Teslas or electric cars going around. But, and I'm not trying to beat up on Tesla. I'm very passionate about electric cars, but we just think if that was adopted widely, proliferated throughout the earth, that probably will be an issue, the recycling of batteries and the mining of lithium. And with hydrogen, there's literally zero emissions. And so if we can get creative about how we produce that hydrogen, we just think that's the answer to our transportation problems and our power problems.
And even utilizing this hydrogen tech, there are still many use cases for battery tech. For example, batteries offer better draw power than hydrogen. So what we see, at least at first, is that hydrogen fuel cell vehicles would likely be kind of a hybrid. The electricity would be used, or the batteries rather, would be used for takeoff and landing because those operations require a huge draw all at once, whereas hydrogen can provide power over time. So if you have a vehicle using both technologies, you can use the batteries to take off, switch to the hydrogen for cruise, which is going to be much more efficient for that application. And also during flight, you can recharge your batteries for landing. And then, so that's kind of where we are today with the technology. You know, there's still going to be a need for batteries.
Sure.
And we're excited to kind of see where that technology is going too. You know, solid state batteries sound very promising. It's probably going to be about a decade or so before we really see them viable for commercialization. But yeah, they still have a place.
Yeah, for sure. Batteries definitely have a place, and the hydrogen really complements the battery. And like we said in our deck, but there's just not really any hydrogen infrastructure. So people are working on, like if you saw Beta, they're working on the infrastructure for lithium ion. But it would be really nice to, you know, combine the hydrogen with the lithium ion because it can extend the range. It can do just lots of good things and not put as much draw on that battery. So,
and there's also kind of an inverse relationship between hydrogen power efficiency and the overall weight of the vehicle. So smaller aircraft like drones, for example, they would not benefit from using hydrogen. So they'll still need to use lithium ion. It's when you get into the larger vehicles, maybe 4,000 pounds, maybe 4 or 5 passengers, that it really, really starts to be viable, and you really see the benefits of that higher energy density of hydrogen.
Mm-hmm. And now we'll sing you a song. Just kidding.
This is like so cool. I'm a freshman in high school and I love aerospace. I love chemistry. What are like some things that you would suggest that I look into to get started in, like in aerospace or something?
I'm so happy that you asked that, Emily. We are so passionate about inspiring younger people, especially females, in engineering. As you probably know, there are not many of us, and so the more friendly and open we can be to that subject, the better. Aerospace engineering is difficult, and so is chemistry, but it's certainly doable. I went back. I was a sound engineer. I had my own company in my 20s and 30s, and then I went back to college in my late 30s and became an aerospace engineer. And I thought I was bad at math, and I was just like, oh, I really want to do this, but it's so scary. I don't know what I'm doing. And I kind of feel like having that attitude actually made me try harder. And I just really like stuck through those classes and ended up doing really good and had a good GPA, and then ended up starting my own company. So definitely get involved, and we can connect you with there's some really cool organizations. There's a nonprofit called Women and Drones. And that's something, they have a lot of cool stuff going on, and there's a lot of educational things for students. There's a lot of cool stuff with NASA. We do some projects. We would certainly love to work with you and give you some, like if you wanted to do like some research or whatever, we could give you some stuff to get started. There are tons of scholarships for women in aerospace engineering. And Vertical Flight Society has really cool stuff for students. AIAA, I know I'm giving you a bunch of stuff, but these are all really good resources for students. And I'm not sure how it works for high school. I know they have special things for college, but the earlier the better. I would get involved with NASA, AIAA, AIAA, Vertical Flight Society, and Women and Drones. And if you didn't catch all that, you can shoot me an email, and I'll be happy to share those resources with you. And you can kind of get a head start. And I know there's stuff that you can do in college. I mean, there's stuff you can do in high school to start knocking out some of those classes, and for sure, start knocking out that math. If you can take any of that calculus in high school, get it done, because it's not going away.
Yeah, and I'll say this too, kind of building on what Danielle was just saying, is that when I was in high school, I didn't do any more science than what was required for me to graduate. I didn't realize I was even interested, and I ended up going kind of back to further my education later in life. And I didn't get that science background during high school, so I think it's great that you're seeing that now and you're looking into it now. Because yeah, I felt like I was at a disadvantage in my classes. Everyone else was like, oh yeah, this is like a review from high school. It's like all brand new to me, but it was still so interesting to me, and I had to put the hours in, but I love doing it. But building that foundation right now, Emily, during high school, that will be so beneficial to you moving forward. So my advice during high school would be, in your science classes, some people, when they study for tests, they kind of do what I call a binge and purge technique. Like they'll learn the material and then they'll take the test and they don't worry about it again. Like they learn the material with that in mind, like that's why they're learning it, so they can take the test. I wouldn't recommend that approach. I recommend learning material so that you know it. Mm-hmm. Otherwise, what's the point, I don't know. I just, building that foundation, I think, would be my advice.
Mm-hmm. And also making friends. You're definitely doing the right thing by connecting with us, and we would love to stay in touch and help you in any way that we can. When I was going back to college, I looked online like how to get involved in aerospace, and literally the question that you just asked, and it said find mentors and become friends with your teachers. And people can be judgy and think, oh, you're trying to be teacher's pet or whatever, but teachers can be, if they're passionate about a topic, can be so helpful. And I mean, my teachers, all of my professors in college, almost all of them, I've had a few rough ones, but most of them have ended up being really good friends and have gotten me jobs, have stayed after for hours helping me understand a topic if I was really struggling on something, especially in some of the harder classes when you get into your upper engineering courses. But they'll just go out of their way. And one thing I love about the engineering community, especially aerospace, I can't really speak for other industries, but in aerospace, it's such a small sort of niche community, and we want more people involved. We have so much fun, and these people are not snobby. They're so open, and they want to get people involved, and we want to get people excited about it. It's just such a fun thing to be involved in. So I don't think you'll ever come across, I don't think you'll come across somebody that doesn't want to help you or share information with you. So it's just a really fun group of people, and make a LinkedIn if you don't have one already. We all kind of seem to be on LinkedIn. I would love to be your friend on LinkedIn, and yeah, so you're definitely doing the right thing by reaching out and asking questions. So kudos to you for doing that.
Thank you so much for taking the time and explaining all of this. It's really cool.
Yeah, happy to.
I will definitely look into those organizations and see what I can do to further my interest.
Okay, cool. Yeah, feel free to add us on LinkedIn and reach out anytime.
Thank you. Have a great
You as well.